We're going to start with some MCQs based on the chapter Thermodynamics. So thermodynamics is what we're going to study now. See, the first question says dialorane is a potential rocket fuel which undergoes combustion according to this reaction. And we are told to calculate the enthalpy change for the combustion reaction. Okay. And you're given 4 series of reaction. Now we have to use these 4 reactions in order to get the final reaction as this. Okay. Now how we're going to do this? See, first of all, understand that we need B2H6 in the reactant side. And in this reaction, B2H6 is on my right hand side. So what will I do? I will just reverse the reaction. So when I reverse the reaction would become B2H6 giving 2Bs plus 3H2. So my enthalpy change would become minus 46 kilojoules. Okay. Next, look at this reaction. H2O is in liquid state, H2O getting converted to gaseous state. So I need gaseous state H2O on my right hand side only. But there are 3 molecules. So I will have to multiply this whole reaction by 3. So what will it give me? 3 H2O giving in liquid state, giving 3 H2O in gaseous state. So even your delta H will get multiplied by 3. So 4 3s are 12, 4 3s are 12 and 1, 32 kilojoules. Okay, that's also positive. Okay, now let's look at this reaction. Now we are concentrating at oxygen first. Okay, see, even if you do not concentrate at oxygen, look at H2O liquid. There is no H2O liquid in this reaction. So this H2O liquid we want to cancel off. That means this 3H2O liquid will be cancelled off if there is 3H2O liquid on the right hand side. So I will have to write this reaction in the same order, but I will have to multiply it by 3. So it is going to be 3H2 plus 3 by 2 oxygen in gaseous state giving 3H2O which is liquid. So even my delta H will get multiplied by 3. So minus 286 into 3 would be 6 3s are 18, 24 and 125. And then 3 2s are 6, 7, 8. So this would become minus 858 kilojoules. Okay. Next, look at the first reaction. Okay. It says 2B plus 3 upon 2 O2 giving B2O3. Now B2O3 we require on the right hand side only in the final reaction. So unchanged, I am just rewriting that equation. So 2B which is in the solid state, 3 by 2 O2 gaseous state, B2O3. Okay. So delta H is remaining unchanged, which is minus 1273 kilojoules. Now when you add all of these reactions, you will get, I'm adding all the reactions, you will get B2H6 plus 3O2 forming B2O3 plus 3H2O in gaseous state. See how B2H6 I have written here. Okay, then on my left hand side 3 upon 2 O2 and 3 upon 2 O2, which means 1.5 plus 1.5 O2, which means 3 O2. Okay, then 3H2O liquid state is getting cancelled. 3H2O liquid state is getting cancelled. 3H2 is also getting cancelled. So I am left with only the products, which is B2O3 and 3H2O in the gaseous state. Now we know for a rule, that delta H is delta H1 plus delta H2 plus delta H3 plus delta H4. So all I have to do is just add all the deltas that is given here. So this would be minus 46 plus 132 minus 85 minus 1273, and this would give me my final answer, which is minus 2045. Okay, so the correct answer is C, minus 2045 kilojoules per mole. Next question. The internal energy change when a system goes from state A to state B. Okay, so what is the energy change? 40 kilojoules per mole. If the system goes to A to B from a reversible path and returns to state A by an irreversible path, what would the net change in the internal energy be? See, the net change would be 0 because the final state is the same and it does not depend upon the path. Next question. At 298 Kelvin, the bond energies of CH, CC, C double bond and HH are respectively given to you. The value of the enthalpy change for this reaction is being asked. So what's the reaction? The reaction that is given is CH2, CH2 plus H2 forming CH3, CH3. Okay. Now, how is the enthalpy change calculated? Enthalpy change is calculated by the enthalpy change of the reactants minus enthalpy change of the product. So for sum total of the enthalpy change of the reactants, we need to add up all the enthalpy, the energy that is required to break each bond of the reactants. Okay, so let's look at this compound first. How many carbon-carbon atom bonding is there? Double bond 1. So 1 into C double bond C. Then this C is bonded to 2 hydrogen and this C is bonded to 2 hydrogen. So in total 4 CH bonds. So that means 4 into CH bond. Then there is HH bonding is 1. So 1 into HH minus CC bond, and now we are concentrating at the product. So there is 1 CC bond plus there are 6 CH bonds. So 6 into enthalpy for CH. Okay, now I'm just substituting the values. So for a C, a double bond C, the enthalpy was 615. Okay, for CH, it was 4 into 414. For HH, it was 435. For CC bond, 1 into, for CC bond, the energy was 347. And for CH bond again, plus 6414. Now if you simplify this equation, your answer you will get is minus 125 kilojoules. So my answer is C. Next. The enthalpies for combustion of carbon and carbon monoxide is given to you. Okay, so let's write down the reaction for the same. Now combustion of carbon means C plus O2 forming CO2, and the enthalpy change is given to us, which is minus 393.5 kilojoules. Okay, and carbon monoxide, that means C plus half O2 forming CO. Okay, this is see why am I writing half O2 is because it is given in the question for per mole of carbon dioxide, okay, carbon monoxide, okay, per mole of carbon monoxide. So if I want to balance this reaction to CO, I will have to write half over here. Okay, so here the delta H is given as minus 283 kilojoules. Okay. Now what reaction we want to get? We want to get what is the enthalpy that is asked? Enthalpy for the formation of carbon monoxide per mole, and here there is 2 moles. Okay, so we want only 1. So what we will have to do is we will have to we want to get the final reaction which will have 1 mole of carbon monoxide in its right hand side. So see what will we get if we do 1 minus 2. This is reaction number 1 and this is reaction number 2. I'm subtracting. Okay. So it is C plus O2 minus C minus half O2 forming CO2 minus 2 CO2. Okay. 2 CO2. So C and C is getting cancelled. Okay. And you are getting, sorry, this is CO, not CO2. See, this was combustion of carbon and carbon monoxide. So this is CO. So this is also CO over here. Okay. The next question says exothermic formation of CiF3 is represented by this equation. Which of the following will increase the quantity of CiF3 in an equilibrium mixture of Cl2, F2 and CiF3? See, this reaction has already reached equilibrium. The first says increase in temperature. So if you increase the temperature, will the equilibrium reaction be increased? No. Second, removal of Cl2. See, if you remove this, even according to Leach et al.'s principle, decrease in concentration of Cl2 will cause the reaction to move from right to left. So in fact, the yield of CiF3 will get reduced. Okay. Increasing the volume of the container. No. Adding F2. If you add F2 according to Leach et al.'s principle, in order to reduce the stress of increased concentration of F2, the reaction will shift from left to right. So in that process, yield of CiF3 will increase. So my correct option is adding F2. Let's see the next question. Standard entropy of X2, Y2 and XY3 is given as 60, 40 and 50 joules per kilomole respectively for the reaction half X2 plus 3 upon 2 Y2 XY3. Delta H is also given to be at equilibrium. You are being asked the temperature. Okay. So first of all, you are given the entropy for the reactions. Okay. So first of all, we will have to, for this reaction, we will have to calculate delta S. Okay. So how much is the delta S? See, for the product XY3, the entropy is given as 50 kilojoules. So 50 minus that of the reactant we will have to do. Okay. So a reactant may 3 upon 2 Y2. So what is the entropy of Y2? 40. So that's into 40 plus half into entropy of X2, which is how much? 60. Okay. So this is 50 minus. So this would give me 20, 3 is 60 plus half of 60 is 30. So this is 50 minus 90, which is giving me minus 40. So delta S is minus 40. Okay. Now we know the equation for Gibbs energy says that delta G is equal to delta H minus T delta S. Okay. Now at equilibrium, delta G will be 0. Alright. Because it has reached a state of constant. So delta H is actually T delta S. Okay. So what is the value of delta H given to you as? It is kilojoules. So we will have to convert it into joules. So that is 30 into 10 raised to 3 would be equal to T into 40. Okay, minus signs from both sides is getting cancelled. See, it was minus 30 and minus 40, so we are cancelling off the negative sign. So what is T? T would be 30 into 10 raised to 3 upon 40. Okay, so my answer is 750K. So my answer would be 750K. Okay, so the correct option is C. Next. So the next question says, if the bond dissociation energies of XY, X2 and Y2, all diatomic molecules are in the ratio 1:1:0.5. Okay. And you are given the enthalpy change for the formation reaction of XY, which is minus 200 kilojoules per mole. Then the bond dissociation energy of X2 is what they are asking you. So let us first write down the dissociation of each molecule. So XY would be dissociating as X plus Y. Okay. And let's say, since it is given in the ratio, let's say the common multiple is A. So the enthalpy change for this reaction would be, delta H would be 1A. Then for X2, it would be dissociating as 2X. Okay, again it is 1 only. So since we have taken the common multiple as A, delta H will be A. And for Y2, it is 2Y. And again delta H will be 0.5A, since the values are given in ratio and we have taken the common multiple as A. Okay, now we want to get the formation, since we are given the delta H for the formation of XY, okay. So what we will do is, let's say this is equation number 1, equation number 2, equation number 3. Okay, if equation number 2 and 3 we multiply by half and add them. Okay, so what am I doing is, equation number 2 I am multiplying by half, plus equation number 3 I am multiplying by half, and then I am subtracting equation number 1. So what will I get? See, equation 2 I am multiplying by half, I will get is half x2 since it is multiplied by half, it is half x2, then plus half y2, okay, minus xy will give me half x2, that means only x, plus half y2, which means only y, minus, so minus x minus y. Since I'm doing equation 1, I'm subtracting from the addition of 2 and 3. So this x, y, all terms gets cancelled. So minus xy, when it goes on the other side, I'm getting half x2 plus half y2 would give me xy. Now whatever I did on the left hand side, I will also have to do with the enthalpy change. So what did I do? I multiplied the second and third equation by half. So that's half of A plus half of 0.5A, and then I subtracted the first equation, which means minus A. Okay, and the enthalpy change for this reaction, delta HF for this reaction is already given to me, which is how much? Minus 200. So this entire thing should be equal to minus 200. Now let's just simplify. This is 0.5A. Okay, so what I am doing is I am taking A common. Okay, so this is half plus 0.5 upon 2 minus 1. Okay, now since the denominator is same, I can add the numerator. So 1 plus 0.5 is 1.5. 1.5 so that's 1.5 upon 2 minus 1. Now how much is 1.5 upon 2? 1.5 upon 2 is 0.75. Okay. So I'm continuing here. Therefore, minus 200 is equal to A into 0.75 minus 1. Okay. So what would this give me? Minus 200 is minus 0.25a. So negative negative cancels. So a is 200 upon 0.25. 0.25 means 1 upon 4. So I can say 200 upon 1 upon 4, which will give me 800. So my answer is 800 kilojoules per mole. Next question. Identify the correct statements regarding a spontaneous process. For a spontaneous process in isolated system, the change in entropy is positive, is correct. So the first statement only is correct. Next is, in conversion from limestone to lime, that is CaCO3, CaCO3 getting converted to CaO and CO2, the values of delta H and delta S are given to me. Okay, so delta H is given as 179.1 kilojoules per mole. I will have to convert this into joules. So 179.1 into 1000 joules per mole. Okay, and delta S is given to me as 160.2 joules per Kelvin. Okay, at a temperature of 298. Assuming the delta H does not change with temperature, the temperature above which the conversion of limestone to lime will be spontaneous is. So we know the equation for Gibbs energy. It is delta H minus T delta S. Okay, but delta G is 0. Okay, delta G is 0. Therefore, delta H is equal to T delta S. Now we want to find out temperature. So temperature we are keeping on one side, just everything on the other side. So that's delta H upon delta S. And my delta H is 179.1 into 1000 upon delta S, which is 160.2. Now if you use a calcium calculate, the answer is 1118 Kelvin. The answer is 118 Kelvin. So the correct option is D. Next. The entropy change involved in isothermal reversible expansion for 2 moles of an ideal gas from a volume of 10 decimeter cube to a volume of 100 decimeter cube at 27 degrees Celsius is. Okay. So here, so we know the equation for delta S. Delta S is 2.303 nR log to the base 10 of V2 by V1. Okay. Now N here is 2 moles, which is given to you. So delta S would be 2.303 into 2. R is constant, value we know is 8.314, and log to the base 10 of 100, since it is 100 decimeter cube upon 10 decimeter cube. Now when you simplify this equation, the answer that you will get is 38.3 joules per mole Kelvin. Okay, so my answer is 38.3 joules per mole. Next, for an endothermic reaction where delta H represents the enthalpy of the reaction in kilojoules per mole, the minimum value for the energy of activation will be. See, let's understand that energy of activation is equal to energy of the intermediate complex minus average energy of reactants. Okay, now let's suppose we plot a graph. This is increase in energy and this is progress of reaction. So first your reactants energy will be here, it will go on increasing till it form an intermediate complex, and then as it forms products, so this is for intermediate complex, products will gain stability, and here there is reactants. So delta H we see has to be more, the energy of activation has to be more than delta H. Next, molar heat capacity of water in equilibrium with ice at constant pressure is, okay, so the molar heat capacity is H2 minus H1 upon delta T. Okay, now temperature is pressure is constant, and the temperature will not delta T will be 0, okay, because it is already reached equilibrium. So delta T is 0. So Cp will be H2 minus H1 upon 0, and anything upon 0 is infinity. So the answer is infinity. Next, let's read this question. Which of the following statement is false? Work is a state function. False. Work is not a state function because work depends on path. So this is false since work depends on path. Next, 2 moles of an ideal gas is expanded isothermally, matlab delta T is 0, and reversibly from 1 liter to 10 liter. The enthalpy change is being asked. So change in enthalpy is NCP into delta T, but we know delta T is 0. So delta H would also be 0. So the answer is 0 kilojoules. Next, the enthalpy for vaporization of liquid is 30 kilojoules per mole, and the entropy for vaporization is this. The boiling point of liquid at 1 atmospheric pressure is, okay, so we know change in enthalpy upon entropy is dQ, that's enthalpy, upon T. So what is T? That's enthalpy upon entropy. So it would be 30, since it is kilojoules, into 10 raised to 3 upon ds value, which is 75. So the answer is 400 Kelvin. So my correct option is B. Next, the value for the log to the base 10K for this reaction is given to us, and we are given the value of delta SR, and R the value is also given. Okay, so we know we are being asked the value of log to the base 10 for K for this reaction, and we are given all these values. So we know delta G is delta H minus T delta S. This is the equation for Gibbs energy, and delta H, change in enthalpy, can be represented by minus 2.303 RT log to the base 10 K. This is the equation. This is also the equation for delta G, and this is also the equation for delta G. So what I'm doing is I'm equating both the equations. So from 1 and 2 I can say minus 2.303 RT log to the base 10K is equal to delta H minus T delta S. Okay. Now we are being asked the value of log to the base 10 of k. So we're keeping this on one side, just everything we are shifting on the other side. So log to the base 10 of k delta h minus t delta s upon 2.303 into, now I'm substituting the values as well, 8.314 into 298. Okay, so your delta h, we just now have to substitute the values, which is 298 into delta s, which is 10 minus 54.07 into 1000 upon 2.303 into 8.314 into 298. See here, your this delta h was minus, right? So this minus and minus will become plus. Okay. And when you simplify this, your answer is 10. So the correct option is 10. The work obtained in a cyclic process is 0 because see, work is indicated by P delta V. Now change in volume is 0 since volume is constant. So delta V is 0 because V is 0. Okay. So delta V is 0. Therefore the work obtained in a cyclic process is 0. Next. 32 grams of oxygen expands from a volume of 10 dm cube to 10 meter cube. Okay, but the number of grams of oxygen remains same. So if I want to calculate moles, okay, so moles is 32 upon 32, which is 1 only. Okay, next, pressure that is given to me as 100 kilopascal. So I will have to multiply this by 3. So P will become 100 into 10 raised to 3 Pascal. Okay. Then your volume V1 is in dm cube, which we will have to convert into meter cube. So this is 10 into 10 raised to minus 3 meter cube, and V2 they are already saying is 10 meter cube. Now we just have to substitute in the formula for work, which says P delta V. So my P is 100 into 10 raised to 3, and this is 10 into 10 raised to 10 minus 10 into 10 raised to minus 3. Okay, so which is 10 raised to 3 and more 2. So this becomes 10 raised to 6 into 1 minus 0.001. 110 has been removed out common, so this becomes one more 10 and two zeros from here. So 10 raised to 3, 10 raised to 3, 10 raised to 6, and this becomes 1 minus 0.001. So which is 9.99 into 10 raised to 5. See, we have taken 110 common, so that it becomes 10 raised to 6 over here. Okay, so my answer is 9.99 into 10 raised to 5. So the correct option is D. The question says which is not endothermic. Now which is not endothermic? See, combustion of hydrocarbons is exothermic. Okay, so this reaction is actually exothermic. Okay, so this is not endothermic. Okay, next question. Maximum work is obtained by 10 gram of which of the following gases? Now remember, work done is inversely proportional to molecular mass. Okay, so the molecular mass has to be minimum. Then NH3 would be having minimum molecular mass. Okay, so that the work done is maximum. All right. Heat of combustion for methane is minus 800 joules. How much heat is required for the combustion of 4 into 10 raised to minus 4 kilograms of methane? Okay. See this. Methane means how many grams? See, methane means 12 plus 4, which means 16 grams. Okay. So 16 grams of methane gives how many kilojoules of energy? 800 joules of energy. 800 kilojoules of energy. In the question only it's kilojoules of energy. Okay. We want to know the weight for 4 into 10 raised to minus 4 kg. 4 into 10 raised to minus 4 kg. Now I want to convert this in grams. So 10 raised to minus 4 into 10 raised to 3 grams. 1 kilogram is 1000 grams. So this becomes 4 into 10 raised to minus 1, which means it becomes 0.4 grams. Okay. So if 16 grams is evolving minus 800 kilojoules of energy, then 0.4 grams would evolve X amount of energy. So X is 0.4 into minus 800 upon 16. Okay. So this is 4 ones are. So this becomes 0.1. 4 fours are. 4 ones are. So this is minus 20 kilojoules of energy. So my correct option is C. Next. 4-liter atmosphere is, you have to convert it into different unit. Okay, so remember 1 liter atmosphere is 101.3 joules. Okay, also 1 calorie is 0.0413 liter atmosphere. So 4-liter atmosphere would be X calories. So X would be 4 upon 0.0413, which will give you 96.8 calories. So the correct option is B, 96.8 calories. Next. Reaction for the formation of sodium chloride is, see here we look into the formation of 1 mole of the compound. So 1 mole of the compound would be formed by option D. Next. Heat of formation for NH3 is 172 kilojoules. To double the Avogadro's number of NH3, what is the change in enthalpy required? Okay, the change in enthalpy would just be doubled. Okay, heat of formation is always given for 1 mole. Okay, it is given for 1 mole. So this heat is given for 1 mole. So if you want to double the number, you will have to multiply by 2. So even the change in enthalpy would get multiplied by 2. So the answer would be 344 kilojoules. Alright. Next. For salt of strong acid with strong base, the heat of neutralization is equal to 57.1 kilojoules. For a salt of strong acid with strong base, the heat of neutralization equal to 57.1 kilojoules. Okay. So here you're being asked the heat of neutralization. So see, if 1 mole of water has to be neutralized. Okay, so delta H would be minus 57.1. Okay. Now, in this question only, it is said for formation of 0.9 kg of water, delta H would be how much? So this is the question asked. Okay, so delta H for 1 mole of water is given to you and you are being asked for 0.9 kg. Okay, So 0.9 kg means multiplied by 1000, it will be 900 grams. Okay, so for 1 mole it is 57.1. So for 900 grams it would be x. So what is x? 57.1. See, when I say 1 mole, it is 18. How? 16 plus 2h. So it is 18. So for 18, it is 57.1. So 18 grams. Delta H is 57.1. So for 900 grams, the delta H, x. So this is this into 900 upon 18. So 900 9 2s then 2 1s 250s. So when you multiply, you will get 2865 kilojoules. The correct option is A. Again I am repeating. See, the delta H value for neutralization of 1 mole, that means 18 grams of water was given, and you were being asked the delta H for 0.9 kg, that means 900 grams. So just cross multiply and you will get the answer. Next. See, here it is asked the enthalpy of hydrogenation in this compounds would be in the order of, remember, enthalpy is inversely proportional to stability. So if enthalpy has to be higher, stability has to be less. So which is the lessest stable compound if we compare these through? So this is the lessest stable compound, then would be this, and then would be this. Okay, so less stability means more enthalpy, which means 3 will have more enthalpy with 2 and then 1. So the option is A. Okay, next. For the complete combustion of ethanol, reaction is given to you. The amount of heat produced as measured in bomb calorimeter. So bomb calorimeter is giving you the amount of heat that is produced, which is indicated by delta U, and that is minus 1364.47 kilojoules per mole. Assuming ideality, the enthalpy for combustion delta CH would be for the reaction will be. So they are asking you delta H. So first of all, find out what is delta N. See, if you look at the gaseous product, 2 moles, and here gaseous product is 3. So 2 minus 3 is minus 1. So delta N is minus 1. Okay, this is for the gaseous product. Now delta H is delta U plus delta Ng RT. Okay. Now substituting in the equation, we know delta U is minus 1364.47 minus 1. Now where is this minus coming from? Because this delta is minus, delta N is minus. So here there is minus 1 into 8.314 into 298 Kelvin upon 1000. Alright. So that would be 1366.93 kilojoules per mole. See, where is this 1000 coming from? The value of R 8.314 into 10 raised to minus 3. So that is coming in the denominator as 10 raised to 3. Okay, joules, kilojoules per mole. Alright. So my correct answer is minus 1366.93. Alright.